Okay, I'd like to finish up sections 10.2 and 10.3 in this video here. So we're on problem 36, where it says that a defensive football squad consists of 25 players. Of these, 10 are linemen, 10 are linebackers, and 5 are safeties. How many different teams of 5 linemen, 3 linebackers, and 3 safeties can be formed? Okay, so if you have 5 linemen, let's say, and you mix up those 5, that still doesn't matter, right? There's still 5 linemen, okay? So so you're going to need combinations here. Now there's 10 linemen total, okay? You're going to choose 5 of them. There's 10 linebackers. You're going to choose 3 linebackers. And there's 5 safeties, and you're going to choose 3 safeties, okay? So you've got 11 total that would have been selected. Now, how many ways can you do that? Well, 10 choose 5 is 252. 10 choose 3 is 120. 5 choose 3 is 10. Okay, so that gives us 302,400 different teams that are possible. Okay. Problem 37 says that there are 20 students in a class, and each student must get a letter grade of A, B, C, D, or F. In how many ways can the grades be assigned to the 20 students if the teacher wants to give, 3 A's, 4 B's, 6 C's, 4 D's, and 3 F's? Okay, so no matter what happens throughout the semester, this is already what the teacher wants to decide. Isn't that a fair system? Okay, so let's say that Tom, Rick, and Steve are the 3 people that get A's. Okay, well, Steve, Rick, and Tom are the 3 people that get A's, right? So it doesn't matter the order that I say that, and those 3 people got A's. So I'm going to need combinations here. There's 20 students. Choose 3 of them to get A's. Okay, after those 3 people got A's, now there's 17 people left that still need a letter grade. Okay, we need to choose 4 of them to get B's. Okay, and then 13 people are still left to get a letter grade. Choose 6 of them to get C's. Okay, and then 7 people are left, so choose 4 of them to get D's. Okay, and then whoever the last 3 people are, you're going to choose those 3 to get F's. 20 choose 3 is 1,140. 17 choose 4 is 2,380. 13 choose 6 is 1,716. 7 choose 4 is 35. And 3 choose 3 is 1. By the way, anytime you've got n choose n, that's 1. Okay, because there's n objects, you're going to select everything. There's only one way that you can do that selection if order is not something that matters to us. Okay, so now most calculators won't give you this result. It'll give you some scientific notation thing. But if you did multiply these 5 numbers together, what you get is 162 billion, 954,792,000 ways. Okay. Problem 38. How many different 8-letter words, real or imaginary, can be formed using the letters in the word remember? Okay, now it could be a real word after mixing up these letters, or it could be just a bunch of gibberish. We don't care. I guess we just want to know the number of arrangements of the word. Okay. So let's say that after we mix this word up, we end up getting an R in the 3rd spot and R in the 6th spot. Okay, now if I switch those 2 R's, I get an R in the 3rd spot and an R in the 6th spot. If I switch those 2 R's, that's not going to matter. Okay, I still have an R in the 3rd spot and an R in the 6th spot. Okay, so combinations are going to be used since order does not matter if you are focused on only the letter. Okay, so there should be 8 letters total. There's 2 R's, there's 3 E's, there's 2 M's, and there's 1 B. Okay, so in the 8 open spaces, you're going to choose 2 of them to position the 2 R's. Okay, so maybe they get positioned in the 3rd spot and the 6th spot, or maybe they get positioned in the 2nd spot and the 5th spot. Okay, whatever. So there's 8 open spots. You're going to choose 2 of them to position the 2 R's. Now there's 6 open spots that remain. The 2 R's have been positioned. So the 6 open spots, you're going to choose 3 of them to position the 3 E's. Okay. Now there's 3 open spots left. Okay, since I've already got 5 set. 3 open spots are left. You'll pick 2 of them to mark the 2 M's. And then whatever the last open spot is, you're going to choose it to position the 1B. Okay? So then if we calculate each one of these, 8 choose 2 is 28, 6 choose 3 is 20, 3 choose 2 is 3, and 1 choose 1 is 1. By the way, anytime you've got n choose n minus 1, that will always be n, okay, just as a note. And so if I multiply these 4 numbers together, I should get 1,680 different words are possible. Now, maybe a more interesting question, I wonder how many of these words are actual words that you'd use. Okay, I would guess probably only 1. I've not thought of another word that's, has these exact 8 letters just rearranged there. So maybe there is, maybe there isn't. Okay. Problem 39 says that gin rummy hand contains 10 cards dealt from a standard deck. How many gin rummy hands contain 4 spades, 3 clubs, 2 diamonds, and 1 heart? Note, a standard 52 card deck is shown below. Okay, we're going to be working more with like a deck of cards in the next chapter, which is the probability stuff. But I'm going to assume that everybody has played cards before. Okay, if you've never played cards or never seen a deck, here's a picture of all 52 cards. Okay, be sure that you know that. Okay, and basically the information to know is that there's 4 suits. Okay, there's diamonds, hearts, clubs, and spades. There's the 2 red suits are diamonds and hearts. The 2 black suits are clubs and spades. There's 13 cards in each suit. There's 4 2s, 4 3s, 4 4s. Okay. Sometimes we work with face cards. Okay, face cards are only jacks, queens, and kings. An ace is not a face card. Okay, that's really all you need to know, I think, when it comes to like playing any games or anything. Like any games, the rules of the game would have to be explained to you in the problem. Okay, so anyway, let's see. How many gin rummy hands contain 4 spades, 3 diamonds, or 3 clubs, 2 diamonds, and 1 heart? Okay, well there's 13 spades. You're going to choose 4 of them to be in the hand. I need 10 cards total to be in the hand. Okay, and by the way, if I got 10 cards in my hand and I mix up those 10 cards, it's not going to matter. Okay, I'm still playing the same hand. Okay, so a combination should be used here. Next thing, I got 13 clubs. I'm going to choose 3 of them to be in my hand. That way I've got 7 total cards in my hand. There's 13 diamonds. I'm going to choose 2 of them to be in my hand. That way there's 9 cards in my hand. And then there's 13 hearts. I'm going to choose 1 of those to be in my hand. Okay, and that way I've got 10 cards total in my hand. Well, how many hands is that? Okay, well, 13 choose 4 is 715. 13 choose 3 is 286. 13 choose 2 is 78. 13 choose 1 is 13. By the way, n choose 1 is always going to be n. Okay, which I think should make sense. I mean, if you got n items and you can only select one, well, you got n choices there. Okay, so if I multiply these four numbers together, I would get 207,352,860 hands are possible with 10 cards in them. Okay, these specifically: 4 spades, 3 diamonds, or 3 clubs, 2 diamonds, 1 heart. Okay. Problem 40 is the last one. So I like basketball, NCAA. So problem 40, the NCAA tournament is an annual competition between 64 different college basketball teams to crown a national champion. At tournament time, which is called March Madness, it's common for fans of the game to fill out tournament bracket sheets and compare them to the actual outcomes, realize that they're all wrong, and then tear them up and then throw them away. Okay. A sample bracket sheet is given below. And how many ways can an NCAA bracket sheet be filled out? Okay, and there's a hint there. First, determine how many games will be played, then use the fundamental counting principle. Okay, so here's an example of like a blank bracket sheet, what that looks like. And so the thing to see here is that now there's 64 games, or excuse me, there's 64 teams that are in the tournament. So 63 of those teams are going to be losing teams. Okay, only one is going to win the whole tournament. So there's 63 losers. Well, how did those 63 losers lose? They had to lose their game, right? So that means that there's 63 games. And there's 2 choices for each game, right? Either team A wins or team B wins. 2 choices. So I've got 2 to the 63rd power. Okay. So team A wins or team B wins 63 times. Okay. If you were to calculate 2 to the 63rd power, which I'm quite sure that your calculator will not do, but anyway, I had a computer do this. 2 to the 63rd power is 9 quintillion, 223 quartillion, 372 trillion, 36 billion, 854 million, 775,808 ways. Okay, so and only one of those is going to be the correct one, where the bracket sheet is all filled out correctly. So, and by the way, I don't know if you've ever done this before, but if most teams, okay, or most players there, you fill out the first round, okay, and I mean you're lucky if you get like let's just say this side, at least half of them correct, okay. I mean, so asking for the whole thing to be correct is quite impossible. I've heard it be explained that if you were to flip a coin 63 times and correctly guess heads or tails 63 times in a row, it's like you got a perfect bracket. Okay, so that's pretty difficult, if you'd say. Anyway, that's all I had in chapter 10 there. So the homework again is in section 10.2 and 10.3. Be sure to look at those problems for me when you get a chance. And give me just a second here. Here are those homework problems. So 566 is 10.2, 580 is 10.3. And we're only going to do 10.1 through 10.3. And where we're headed next is chapter 11 there. Okay?